now we're recording, I think. Yes. So by staying on this call, you consent to being recorded. If you don't have your camera on and you don't have, and you never talk, it won't be a problem, like you won't show up anywhere. But if you do choose to talk, that's your decision. It will show up in the recording, just to let you know. The recording will be posted on our website, AIChEProjects.org. Highly recommend you check it out. It's a great website. This workshop, like I said, is intended for beginners looking to have previous experience. And just a fun fact for you all to know is that I wrote this presentation in LaTeX, so you can do all sorts of things with LaTeX. It's very, very versatile, very fun. Okay. So just a few logistics. You'll need an Overleaf account. If you don't have one already, you can use, it's a free account. Just sign up at overleaf.com. It takes like 5 minutes to do. You can do it while I'm talking. It's also free. It's very nice. You can do all the LaTeX things you could ever wish for. We're going to have a Q&A session towards the end of the event, and that's where you can ask us about anything LaTeX related, AIChE projects related, AIChE related, other things related. Until then, we'll be keeping everyone's microphones muted, just so we don't get clashes of noise everywhere. LaTeX is sort of a coding language, so this is why I chose the word use code. If you have trouble with your code, please privately message me, Jared, or Nick during the Zoom chat. We can help you out with anything that might be going wrong. If you think other people are having the same problem, please just message everyone in the chat, and Dr. Drews will be able to help everyone with that. Okay, with that, I'm going to hand it over to Renee.
All right, hi everyone. So let's get started with what AIChE is. So AIChE stands for the American Institute of Chemical Engineers, and our mission is essentially to promote the professional development of chemical engineers at UCSD. And along the way, we also aim to foster a community among our members through various events like social activities and career building events. Throughout the year, we have various professional development events such as info sessions with industry and resume critique workshops. And then we also have networking events such as faculty mixers and alumni brunches. And we host social events as well, such as game nights, factory tours, and movie nights. And in February 2021, which is in winter quarter, we have the biggest event of the year coming up, which is NICHE, which would be a competition as well as a career fair for chemical engineers. So definitely attend that event. It's going to be great. And as for upcoming events, our next event is our general body meeting, or GBM, where you can learn more about AIChE and what it can do for you. And if you want to attend the event, then please feel free to RSVP at that link over there, and we can send you the Zoom link so that you can attend the event. Right, so ways to get involved in AIChE. So there are multiple ways you can start your involvement in AIChE. The first one is through the AIChE committee. The committee basically plans events for AIChE throughout the year. And we have two committees. So the first one is the external committee, which plans industry events and also interact with the department to plan those events as well. And then we have the internal committee, which focuses more on the internal aspect of AIChE. So they plan social events, they plan mentorship workshops and fundraising events. And if you're interested in joining either of these committees, then please scan the QR code, which you will be seeing in a few slides. And then the second way to get involved with AIChE is through our family program, which is a mentorship program to connect older students with newer students. If you're a mentor in this program, then you get the chance to hone your mentorship skills and communication skills. And you also get the chance to pass on your wisdom to your juniors. And if you're a mentee in this program, then you get to learn all about classes, what careers you can have as a chemical engineer, and also gain more advice from your mentor. And the third way to get involved with AIChE is through AIChE Projects, for which we will talk more about on the next slide.
Hey folks, I'm sure that a lot of y'all are familiar with AIChE Projects since we're hosting this event, but in the case that you are not, just going to talk a little bit about projects. Also, I'm Jared. I'm the research coordinator for AIChE Projects. So our mission is to promote team-oriented, hands-on experiences for students, as well as collaboration with local nonprofit organizations and industry. So all that stuff that you just read about AIChE and that Renee was wonderfully presenting about, we're the project team aspect of AIChE at UCSD. We currently have 5 project teams hoping to start a new, brand new one this this quarter. More news to come, and if you're interested in that, feel free to check out our website. Teams focus on a range of topics from water treatment to renewable energy optimization, but in general, they're all environmentally focused and seek to have a direct impact on the world around us. Our next event for AIChE Projects is Fall Welcome Night. Each and every team will be giving a presentation, and there'll be a poster session. We can talk to each team. This is so that teams can illustrate the various work that they've been doing, as well as kind of recruit and see which people are interested in potentially joining the team. If you're interested in that event, it's going to be Thursday, November 5th, 6:30 to 8:30. All the information is largely going to be hosted through our website, aicheprojects.org. .org? I'm pretty sure it's .org. .org. Great. aicheprojects.org. And for any information, any and all information for AIChE Projects, please do go to that website. You can also find us on, or AIChE in general at UCSD on Facebook and on LinkedIn. And we'll be posting regular updates on whatever events and programs that we'll be hosting. Another way that you can access all that stuff is the following slide that houses all the very lovely and nice QR codes, so you don't have to type in any links if you're particularly lazy like me. So you can just go ahead, pull out your phone, scan the QR code, and very easily follow us on all those different platforms. And yeah, if anyone has any questions about AIChE or AIChE Projects, feel free to drop them in the chat for now while we have folks scan those QR codes and, you know, hit the like button, hit the subscribe button on YouTube. Yeah.
I think now's the time that we'll start the little bit of Kahoot.
Yeah, so you know, guys, just to get ready to, you know, learn a little bit, get, you know, the blood flowing to our brains, and you know, just get a little bit engaged because we have some extra time before Dr. Drew's supposed to show up. We're gonna have a quick game of Kahoot with questions ranging from, you know, questions about the presentation you just saw to random questions about engineering and chemical engineering at UCSD. So I will now share my screen and we can get a little Kahoot action going for like the next, like, 10 minutes or so. Let me share screen here. Does anyone know how to like share the audio so that I can have you guys hear this wonderful music? Oh.
I think if you go into the ellipses that are the bar that has like participants, share screen, and all that stuff, it should have share computer audio.
Yeah, can you guys hear it through this?
We can.
Okay, I'm not technology, so this is what we'll do. All right, cool. Yeah, just try to get in. We'll give it like another 30 seconds.
Nick, if anything, you can also narrate the questions. If you'd like to keep your sound on.
Hold on, sorry, what was that, Diana?
You can also narrate the questions if you're going to keep your sound on as well. Okay.
Sorry, say that again, Diana.
If you're keeping your sound on, you can also narrate the questions as they come.
Oh yeah, that's facts. Okay, cool. Let's cool. Let's get ready to go here. If you can hear me, I'll try to keep the music at a chill volume. All right, let's do it. Let's start this game. So the first question is, what is the AIChE Projects website link? Answer. It could be any of these. Oh wait. Yeah. Sorry. Nice. Good job, guys. Easy one, easy one. Next question. What program was this presentation written in? I think another gimme if you were paying attention. Shouldn't be too hard. Shouldn't be too hard. Yes, yes, you can get free housing if you win, for sure. So yeah, easy one, LaTeX. Obviously, Eleanor did a wonderful job on that presentation with the LaTeX. All right, cool. So when is our next event, or what is our next event? Sorry. The stakes are rising. All right, easy. Wow, okay. It's good to know that everybody's paying attention. I guess everybody will learn LaTeX super well. It seems that everybody is really into this. So it looks like we have Howard in the lead. Shout out Fuel Cell. Next. How many project teams are there at this moment? Wow, okay. Okay, a little bit harder, you know. Good job, everybody. There are 5 teams. There may be a 6th at some point in the near future. But yes, all right. Spark. Good job, good job. Holding on to a narrow 5-point lead. All right, the next question, a little bit harder. Double points for this one. So which of the following professors at UCSD won the Chemistry Nobel Prize? I guess, like, I would not encourage you to look it up online, but, like, because you might lose a bunch of points, but, like, I don't know. I guess we can't really stop you, can we? Should have made the time limit quicker for sure. Oh, nice. Good. Okay. Weeding out the real nerds here. This is a good one. I like this. All right. Here. All right. Spark with the lead. Very nice. Very nice. So which building on campus do nano and chemical engineers meet? It's like the home of the nanoengineering department. There is no sleeping allowed in this building unless you're in a lab. So structural and materials engineering, that is correct. That is the correct answer, obviously. Yeah, great building, love that building. Spark still holding the lead, but Steven coming in pretty hot right now. And when is fall welcome night? So this would be the AIChE Projects fall welcome night. Coming up on the blank of November. It might be the 4th. It might be the 5th. It might also be the 6th or the 7th. I actually don't know. Just kidding, I do know. Good job, everybody. 13 people, majority. Solid. All right, next question. How many classes are in the non-lab Physics 2 series? A little bit of UCSD classes trivia, you know. There's actually like, I think it's not what you would think. Unless you really know. Yeah, exactly. There are infinitely many classes in the non-lab Physics 2 series because, you know, we do physics every day in our daily lives. When we hold something in our hands or mentally weighing it, that's physics right there. Cool. So 14 people got it right. It is 4 classes. There is actually a Physics 2D, fun fact. Some of you might have taken it. I have not. I, you know, personally decided to end at 2C. So yeah, Weld-Spark, still holding on to the lead. I wonder who Weld-Spark is. I wonder who it is. It's not me. So yeah, what is the name of UCSD library? This is a gimme. Unless, yeah, perfect. I guess for the 3 and 2 of you who got it wrong, it's okay. That's actually, maybe if you don't know the library, maybe that's a good thing. Maybe it means you've been doing other things with your life outside of studying. All right. What kind of event does AIChE NOT do? I mean, we're an engineering event, right? Maybe we like don't have any social events. I mean, an engineering org. But since 20 of you already answered psych, we do have social events. Nice. Wow, that was great. Well, there is an AIChE conference. It's just not affiliated with UCSD. Cool. So that is Weld-Spark. Still in the lead here, but the leaderboard is constantly changing every question. What does AIChE stand for? Americans in Chemical Equilibrium. As humans, are we really ever in chemical equilibrium? I do not think so. Oh, nice. Good job, everybody. Yeah, a lot of people got that one. I like that. That was more of like, a visual trick one. Oh, but Weld-Spark falls. Oh no, Steven taking over the lead here. We have, I think, we have 4 more questions. This one is double points. When was the nanoengineering department founded? If you didn't know, the nanoengineering department encompasses the chemical engineering department. But I believe chemical engineering was at UCSD prior to nanoengineering. And then the department sort of merged in this amazing year. Nice. Whoa, nice. 16 people knew that. I did not know that until a couple days ago. So, wow, yeah, good on you all for knowing your UCSD nanoengineering history. Steven still holding on to the lead narrowly over Weld-Spark, but Bert, Randy, and David all charging from lower down in the leaderboard. 3 more questions to go. Yeah, so what mechanical engineering course are we required to take as chemi? If you're not chemi, and maybe you're nano-e or another major, you might have had to take this course as well. Pretty great course. Yeah, nice. I see we all, have stared at those 3 letters and 3 numbers so much throughout the last, maybe it was this quarter, maybe it was last quarter, maybe it was, last year or the year before. How do you pronounce law? Yo, no. How do you pronounce LATEX? Sorry guys, almost gave it away there. Thank you, Hannah. I try. God. I probably should have planned for that and thought of it, but yeah, I did not. Hey, there were 2 right answers because it's up for debate. We here at AIChE Projects are firm believers in LaTeX, but you'll often run into the rogue professor or student who is willing to debate you and tell you that it's pronounced LaTeX. But I think if you go on Wikipedia, there are both pronunciations are there. But I believe the original founders wanted it to be called LaTeX. So, double points question: what branch of AIChE is hosting this workshop? This could change turn the tide for some of you at the top of the leaderboard. It's all about speed here. It's all about speed. This is the last question, by the way. 3 people. 3 or 4 people still have to answer. Oh yeah, for those of you who have joined in the last 15 minutes, we've been playing Kahoot. Yeah, but this is the last question. Good job. For those of you who got it wrong, now you know. Now you know that this is indeed a workshop hosted by AIChE Projects. Now let's see who our winner is. In 3rd place, we have Bert. Good job, Bert. Congratulations. In 2nd place, Steven. Steven, I thought you would pull through for the win. And in 1st place, Weld Spark. Hey. So congratulations to those. Oh, and shout out Randy and Rebecca as runner-ups. Solid work, everybody. There were some tough ones in there. But yeah, great job. Hope you guys are all ready to learn some LaTeX now. Hope your brain juices are flowing and your neurons are firing at maximal capacity. I don't know. Not a neuroscientist, but yeah, thanks for playing. Cool.
Okay, we're going to switch back to my slideshow for just a little bit so that we can talk a bit about LaTeX introduction, and then we'll get started on our actual workshop. Nick, do you want to take it away?
Yeah, what's up, guys? My name's Nick, AIChE Projects Leadership. So I'm here to give you guys a real quick introduction to LaTeX via this amazing slide that Eleanor put together. So LaTeX is a typesetting program, which is essentially a cross between a Word document and a coding language. So basically, you go into your workspace in Overleaf, which you may have seen, and you just sort of, type in your code, you set up your document, define a bunch of stuff, and then you you just go to work and you just write in the various functions and whatnot required to make your math equations and general documents. And it is not just math, however, for homework it is super useful to be able to and super easy to be able to input your equations as such. So yeah, you basically do that and you get a beautiful equation such as this. Or the poster for this event, I don't know if any of you seen it, that was also done in LaTeX. There were a couple equations on there. And yeah, so I guess according to the website, LaTeX is the de facto standard for communication and publication of scientific documents. So a very valuable skill, whether you're gonna use it for homework, whether you are a researcher who is looking for a clean and easy way to present their work. I think not many people would consider coding quote unquote easy. However, compared to the equation editor in Microsoft Word, I would say that LaTeX is incomparable. It's significantly better and significantly easier, and honestly in many ways more intuitive than that. So yeah, LaTeX, pretty great thing. Definitely would recommend learning it, and it's amazing because we are about to learn it. So yeah, Dr. Drews gets here. We will learn LaTeX.
Okay, just to let you guys know, we are still waiting a little bit for Dr. Drews to join, but just a little introduction about him. He is, once again, our LaTeX master. A lot of you may have already had him as a professor for your classes. Give me a minute as I list all the classes that he teaches. He teaches Senge 4, 15, 100, 113, 176A and B. So if you haven't had him already, you'll probably have him for another class in the future. Professor Drews makes lots of the chemical engineering curriculum very accessible, very manageable to consume for your brain. He posts a lot of his lectures on YouTube, actually. So if you're ever interested in, learning some fluids for 101A or some Senge 113, you can just, Google his name on YouTube and watch his lectures in your free time. He also wrote the textbook for Senge 113. So if you haven't seen that yet, go ahead and take a look at it. Just Google Senge 113, Aaron Drews textbook, and you'll probably find it in the first few things. As Hannah says, so cool, and it's free. Wow. It's very cool. He puts like quotes for like Harry Potter and stuff in it. So it's very manageable, very digestible material, and it's absolutely wonderful. He also has 2 dogs named Muir and Winston Churchill. So if you have him as a professor in an online format, just, ask him to see his dog. Sometimes they'll just hang out with him. A little bit more about him. He also plays a lot of video games. So he might show you his gameplay as you're waiting for class to start. Does anyone else on leadership have anything to add?
I can add something about LaTeX that I'm sure that Dr. Drews will also bring up, but oh yeah, Harleen just dropped a link again. In order to participate and code along with Dr. Drews as he goes through things, please be sure that you have an Overleaf account. That only takes like 5 minutes or less to set up. And there's nothing to download, it's just through your web browser. But the other thing I was going to say was a lot of LaTeX things are already like on the internet and open source. So about like 85% of the time, you won't even have to code anything from scratch. You'll mostly be looking for templates. On particularly Overleaf, they have templates for different types of research papers, different types of presentations and formatting and things like that. So yeah, make use of the things that are already there as opposed to coding things from scratch, and then you just kind of mess around with it and fill things in as you go, as with a lot of other coding things.
Yeah, exactly. Yeah, and as with a lot of like other coding languages, there's like, different packages and just various different things that you can use. So that can make your life much easier. But yeah, so I think it's definitely necessary though to know, the fundamentals, how everything works. So when you do go into those templates or whatever, or if you want to write your own document from scratch, which pretty tough, but is good. Definitely looks super nice, and once you know how to do it, it can be very efficient. Then yeah, you'll know how to do it. So
just a note about Dr. Drews. He just talked with me and said that his Windows has decided to update, and so it's just waiting to finish. He says he'll hope to be here in the next couple of minutes. But while we're doing that, I can show you guys a little bit around Overleaf and just kind of the very basic introduction to LaTeX. So, question. Let's see if I can get you to see this screen. Can you see the Overleaf screen? Yes? Thumbs up in the chat or yes?
Yep, looks good.
Awesome, thank you. Okay, so this is the screen that you see when you first log into Overleaf. If you don't have an account yet, you'll see something over here that says something like register or sign in. I've had my account for a while, so I just keep the password in here. You log in, and it sends you to this page where you have all of your projects. Actually, let me show you guys how I did the LaTeX workshop slides, because that's what you were seeing earlier today. So it shows all your projects. You could have different folders for the different things that you want to make LaTeX things for. Like for 2CL, I did all of my lab reports in there. Phys 87 is a freshman seminar that is specifically geared toward teaching you LaTeX. Linear algebra, I was required to use it. I took it at a different college and it was very fun. But anyways, let's get into the nitty-gritties here. This one is probably not the greatest example because I got it from a template and the template is in Portuguese. But we can work with this, and it'll be interesting. So the first thing that you're going to see in all of your LaTeX documents is something like this, which tells LaTeX about what to expect, like what kind of document you're going to make. This one is a beamer, which I believe is what they mean for the LaTeX slides. And then you'll see down here, we have these things called use package, and that allows you to do different things. Like LaTeX itself has certain capabilities, and but if you add packages, that allows you to do more things. It's like going to a library and checking out a book, that kind of feel. And I have news that Dr. Drews is here. Dr. Drews, are you here?
Yep, I'm here.
All right, welcome. Do you
Thanks
need a
for
couple
having
minutes, or are you ready to get started?
I think I'm ready to go. Could you add me as a co-host, and then I can share my screen too?
Absolutely. We are so excited you're here.
Me too.
We're just
I
talking.
love LaTeX, so this is great. Anytime that LaTeX is great.
What do you like most about LaTeX, would you say?
Well, I have to create a lot of the same documents over and over and over and over again. And so it gives me that ability to keep all of the documents looking nice and similar. And just nice and clean is what I think. But, you know, that's just me.
All right. I believe I made you a co-host, so we should be good to go.
Okay. I will share a chunk of my screen here. Go ahead and start my video too. There's no reason that you guys can't see me. There it goes. Hi, Diana. I see your name in the chat now. Okay, so Eleanor, could you give me a quick sort of overview? I noticed when I came in that you were already talking a little bit about LaTeX. Is everybody already in Overleaf? Can I jump straight to that?
Yeah, everybody should have an Overleaf account, and we should be all set up to go. I was just showing them kind of the basics of like how you get into Overleaf and click on projects and things like that. I didn't get very far.
Okay, cool. So if you're currently in Overleaf in another project, back out of that until you get to the Overleaf homepage, and then click on New Project, and then Blank Project. So I'm going to wait here for a minute for everybody to kind of get on the same page, and while I do that, I'll tell you a little bit about what LaTeX is and why you might use it instead of Word. And I apologize if Eleanor already covered this, but maybe I'll just give you a different view of what LaTeX is. And also, like everybody else, I am working from home, so there are 2 dogs who may interrupt us from time to time. So I don't know. They just went on their walk, so they should be pretty quiet. So LaTeX is slightly different from Word. The general idea of LaTeX is that what you want is what you get. In fact, that's the categorization of this type of editor. And so you don't edit the actual document that you're going to send out to someone. You edit what's called the source code for that document. And then that source code is compiled to build your final document. And that's contrasted with something like a Word or a Google Docs editor, which are generally categorized as what you see is what you get. So exactly the same thing that you see on the page itself is what the document ends up looking like. And those, they kind of remind me of finger painting. which is not necessarily a bad thing. But if you think about the way that you get a Word document to look the way that you want it to, if you want something underlined, you sort of click and hold with your index finger and drag over the text that you want to be highlighted, and you click bold or highlight or whatever, right? So it kind of feels like finger painting to get it just the way that you want it. And Word is great. I'm not going to say that LaTeX is inherently better than anything else. It's just different. It has a different skill set to it. And so LaTeX is great if you need something to look really good, but you only need one of them. So LaTeX handles its spacing between letters and paragraphs and all of that, in my subjective opinion, better than Word does. It is also really good anytime you need to write a technical document. So anything containing pretty much anything beyond just text. So math equations, figures, tables, footnotes, bibliographies, tables of contents, that sort of stuff. Anything beyond a basic text document. LaTeX has some built-in features that are more user-friendly once you get to know them. And then if you ever need to do the same thing over and over and over again, it's very easy to make different templates that you can apply to different documents. The things that it doesn't do as well are collaboration. So Overleaf is actually a great document or a great platform if you're going to collaborate with someone, but only if they already know LaTeX. And so that's an obvious drawback if the people that you're going to collaborate with don't know LaTeX or aren't willing to learn a little bit about it. Overleaf will work just like Google Docs and allow multiple people to edit at the same time. But if they don't know at least the bare bones, like a 20-minute intro to LaTeX, they probably won't be able to edit it. And then it's not as good if you need a really quick document. So if you just need to write a letter to somebody, if the company that you work for, either now or after you graduate, already uses Word for everything, they're probably not going to appreciate it if you give them a LaTeX document, because it'll just be the PDF and they won't be able to actually edit the PDF directly. And so those can be potential drawbacks of using LaTeX over something else. So it kind of comes down to your use application. I use it a lot for creating homeworks and exams and reports, that sort of stuff. So we're going to look at the basics of LaTeX in the context of creating a homework assignment, because I felt that would be closest to the type of document that you might have to make right now. And we'll just be kind of brushing the top of some of it, but I think it'll give you an idea of what LaTeX is capable of. And I will also keep an eye on chat. So if you have any questions or anything, please feel free to show them up in chat. I've also got my mouse highlighter on, so hopefully you'll be able to see where I'm clicking. So if you're on your new project window, you can name this anything you want. I'm in the habit of not putting spaces in any of my project names. So I'm just going to give this a name of homework example, right? And that'll create us a project. White spaces tend to be bad for the same reason they're bad in coding environments, because editors have trouble interpreting white spaces. Okay, so this is the basic view of really any LaTeX editor. So we're using an online version. There are free ones that you can get installed on pretty much any system. I would recommend trying to use them on Windows and Mac if you can. There are ones for Linux as well, but they have some of their own drawbacks inside of them as well. Generally, they're all built of 3 windows, right? The one over here on the left is your file browser, which we're going to use a little bit of in a moment. The one in the middle is the editor window, which right now we're seeing the source document. We usually don't switch to rich text because it's kind of funky. It's kind of hard to see what's there. We're going to use the source view. And then over on the right is the compiled document. In order to compile a document, in order to go from your source material over to your finished document, you have to do what's called compile. Usually everything gets compiled the first time automatically, and so the button always reads recompile, as in compile it again, because it's already been compiled once. Most of the editing that you're ever going to do will be over here in the source. There's very little editing that you would do anywhere else, just because that's the way a what you want is what you get editor is built. So if you have this sort of default template, blank template set up already, the first thing that you can do is delete everything that's there. We're going to start from a completely blank form. And we're going to do that so that I can delineate the different sets of, or the different sections of the source document. So the one that comes up at the top is called a preamble. You can comment your source code with a percentage sign, much like you can a lot of other languages. And so the source document is divided into a preamble that's up on the top, and then the body of the document comes underneath that. So we're going to leave the preamble up here, and we're going to leave a bunch of white space because we're going to fill in some stuff down here, and then we're going to put the body of the document down here. Just real quick for everybody, if you could go into the participants window and give me a thumbs up if the font size is okay on the editor window, and a thumbs down if you want it to get a little bit bigger. Okay, pretty much thumbs up on all of it. This is, Eleanor, this is all being recorded, right? So they'll be able to review it and go back and see anything they missed?
Yeah, it should be covered.
Okay, so font size is okay. All right, so you can read all of that. The bare bones that you ever need for a LaTeX document are two things. You need to tell it what kind of document you want to make and where the document goes. So what kind of document you want to make is called a document class. The most common class that we use is article, which is just a general document. There are other classes called books. Presentations are called Beamer. What's another document class that I can't think of? I don't know. Article and book is about the only two that I've ever used, and Beamer occasionally for a presentation. So in order to tell LaTeX what we want in terms of our class, we're going to say document class. This slash, which I believe is a backslash, I always get the back and the / confused, is how you tell LaTeX, I'm going to give you a function. So there are functions built into LaTeX the same way there are functions in any other computer programming language. And so our function is going to be document class, and we're going to give it an article. LaTeX default symbol for inputs to arguments or inputs to functions are the curly braces. And so we're going to use a fair number of curly braces, and those delineate the input to a function. If you want to change your font size, I saw there's a question over in chat. Yeah, Joy is right. Go over here to menu, and then a little further down over here is your font size. So you can set that to be whatever you want. That's setting the font size of the editor. It's not setting the font size in the actual document. So the second thing that you need to tell LaTeX is, where does my document go? In order to do that, we have to define what's called an environment. So LaTeX uses different environments to say any text in between or within this environment should be typeset in a particular way. So for the general document, we define it as beginning with a begin document function and an end document function. So this combination of begin and end establishes what's called the document environment. And we're going to look at a couple of different environments. We're going to look at equation environments and figure environments. There's lots of different environments inside of LaTeX. It just depends on what you're trying to do. So like any good programmer, we'll start off with a hello world example. So if we type the word hello world in there and then click recompile, we will get our very first LaTeX document. So I click the recompile button up here, and I'll just zoom out a little bit. You can see the word hello world is in there. And it's kind of placed in a funky section of our document, right? It's way over. It's about 2 inches over and about 2 inches down. And then the page number, if you scroll around on there, seems to be pretty far up. Those are all elements of the document layout that are typically handled in the preamble, which is separate from the content. So a workflow concept in LaTeX is somewhat different from the way that workflow in Word looks. Word, you kind of add content and then jiggle it around a little bit until it looks right, and then you go to the next one, you add a little bit more content and mark it up, make sure it looks okay. The idea of LaTeX is you set the way that the document is supposed to look first, the way you want the document to look first, and then you focus on adding content afterwards. If you're adjusting something to make the document look a particular way, it's probably going to be done in the preamble. There's a little bit of minor adjusting that can be done down in the body of the document, but the majority of it is done up inside of the preamble. In order to adjust the way the document looks, we usually use things that are called packages. Packages are free. Packages are also the reason the learning curve for LaTeX used to be quite large, because you have to, if you're going to use it on your own computer, you have to get something called a package manager, so that you have something that will automatically go find these packages and install them when you need them. That was removed when people came up with something like Overleaf, which handles all the package management for you. All you have to do is tell it, I want to use a particular package. And so this is much easier now. An example use of a package is the geometry package. So we use the default or the built-in function called usePackage. And if we wanted to use geometry as the package, we would say usePackage geometry. And that shows up in our preamble. It hasn't done anything yet. The geometry package by itself doesn't do anything. We have to give it an argument. And there are several different ways to pass arguments to packages. The easiest one for us, and the one that we'll use most of the time, is the square bracket. So for example, if we wanted to set the margins of our document to be 1 inch, we would add in a square bracket just before the word geometry and curly braces, the phrase margin equal 1 in. And that says, please set everywhere in this document the margin to be equal to 1 inch. And so if you add that bit of code and you recompile, you'll see the text kind of shifts around, right? The hello world got pushed a little bit further up to the left and a little bit, the page number 1 is down near the bottom. So it's a little bit more neatly placed. If you want to do more things to your document, like I said, that's generally going to happen up here in your preamble. So I'm just going to do 2 that are quite common. One, I'm going to change the font size to 11 point, and that will affect almost everything in my document. All of the major elements of text will now be 11 point, and I do that by coming here next to article and putting in square brackets 11 point. So the square brackets denote an optional input argument to a package, or in this case, a function. So they don't always show up, but if you have something as an optional input argument, it'll show up probably as square brackets. A couple other packages that we're going to use really quick, which come up pretty often. One is the math PTMX document. Which is a way of changing the font face to something that's got good math support. So we often want a lot of symbols in our document, and math PTMX is a way to basically say use Times New Roman with an expanded symbol set so that math works everywhere. We're also going to use a package called AMS Math. So the American Mathematical Society has its own package for LaTeX that sets spacing around things like, or it sets conditions for things like how tall is a parenthesis, where does the text go above a fraction and below a fraction, how does it handle alignment like that, and that's the math folks coming up with that, so it generally looks pretty good. And then the last one we're going to use, we're going to add a couple of these in a moment, is the lipsum package. So if you've ever designed a document like a web page or something like that, you may have heard of lorem ipsum text, which is just filler text. It's some chunk of Latin from some book that was published, who knows when. It just fills up text so that we can see what the layout looks like. So instead of hello world down here, if you just type /lipsum, it's going to give us 4 or 5 paragraphs of junk text. Right, it'll just fill up the block or fill up the page with junk text just so that we can see what the layout looks like. And it gives you a slightly better idea of what your document will look like when it's all done. So we're just going to use lipsum whenever we need to fill in space in our document. Normally, you should not turn in a document with lipsum text in it because it's just filler text, right? Nobody wants to read filler text. It is actually telling a story of something. I just don't know what it is. So that's the preamble. We'll come back to it in a little bit as we add more and more stuff to our document, and we want more and more capabilities in our document. But we're going to start off with the most common for, I would say, STEM. Most science and technology and engineers use LaTeX for is math. If we're going to prepare something like a homework document, we usually want to be able to subdivide our homework assignments in such a way that we can see where each problem starts, do some math for that problem, and then go on to the next problem. There are lots of different ways that you could denote the beginning and end of a homework assignment. The easiest is to define it as a section. And so LaTeX has a built-in function called section. So that function is /section. And you could call it anything you want, right? So for example, problem 1, if that's what your problem is, maybe the first thing that we want to do is learn how to enter math expressions. So I'm going to put all of that inside of the curly braces for problem 1. I'm going to hit recompile. By the way, I'm hitting recompile way more than I normally would. I'm doing that so that you can see each of the updates. Normally we would only hit recompile after we've written a chunk of stuff, and we just want to see what it looks like. And so notice that a couple of things that have happened here that we didn't tell LaTeX to do. And I'm going to zoom in on this a little bit. One of the most obvious things is that this text has now gone from regular text to this bold text that's a little bit bigger. We didn't tell LaTeX to do that. We also didn't tell LaTeX to put the number 1 next to it. We said do problem 1, but we didn't tell it to put this little number 1 next to it. This is one of the many useful things of LaTeX is it handles a lot of stuff automatically and takes that heavy lifting off of you to remember what does that formatting look like everywhere in my document. If I want sections elsewhere in my document, they're all going to look the same because they're all going to use the same section function in order to create those parts. If we want to get rid of that 1 here, which we often do because we don't want it to be numbered, if you put an asterisk next to the section here, that says, please get rid of the number. And the asterisk is used frequently to get rid of numbers when we just don't want them to show up. So we've got our section header here that says, I'm going to start with problem 1, which is entering a math expression, right? Some kind of math expression. Normally we would just start typing. So if we were going to start typing with maybe the Pythagorean theorem, which I can spell better when I'm not trying to say exactly what I'm trying to type. So sometimes you'll see me make typos in here, but that's how it goes. We need an environment for math. If we ever want to give an equation, the environment that we use in order to create an equation is the equation environment. And so that begins with a begin equation and it ends with an end equation. Right, so there's a pattern there that's very similar, right? We used begin document, end document to say everything in between here is part of my document. If it's not in there, it's not part of my document. We've now, within our document environment, we've said we're going to define this sub-environment, call it an equation. And everything that appears in there should be typeset as a math equation. And so the Pythagorean theorem is just a squared, can't see my caret here, plus b squared is equal to c squared. And I'm going to recompile that. Again, normally I wouldn't recompile quite so often, but this is a demo, so we're recompiling a lot. Right, so we get a nice math equation here. Again, lots of stuff happened that we didn't tell LaTeX to do. It italicized the A, it italicized the B, it raised the 2 up where it needs to go, it centered it, it kind of changed the font a little bit, and it put an equation number next to it. All of that is the default behavior of LaTeX, and we usually want that to happen. If you don't want it to happen, there are various ways around it. So there are shortcuts to some environments that we can talk about in a little bit. Remember that asterisk thing. If your environment is numbered, you can say begin equation. Ooh, I think it was actually begins. I'm going to have to remember where my, yeah, this time the star actually goes inside. So if you put begin equation star and end equation star, that will get rid of the number that goes next to it. So you'll notice there's no number sitting over here. That can be nice if we're creating a homework and we don't need things to be numbered everywhere. Maybe you don't want the number to be involved. An entirely equivalent way of writing that is the shorthand math, which I think you'll probably be more interested in for the majority of your homework, because it would allow you to write an equation very quickly that you don't need numbered and you don't need to refer to it anywhere else in your document, right? You're just gonna, it's kind of a one-off equation, which is the majority of what math homework or engineering homework tends to be. It's not like you're going to need that equation anywhere else. And so if you use slash with a square bracket, that is a shorthand notation for a math environment. And so you can write the same thing there and get the same result with a little bit less typing. So instead of beginning equation star and end equation star, you can just use those square brackets and get the same thing. So I took the star off of the equation environment to kind of show you the difference between the two. And so that can be a nice shorthand, right? It kind of saves your finger a little bit of typing. The other thing that goes along with math almost all of the time is some reference to those symbols in normal text. And so often underneath here, we would say something like where A and B are the short ends of the triangle, and C is the hypotenuse. And so if you just write it that way, LaTeX won't know that the A and the B and the C are math. And so if I zoom in here really close, you'll see that the C is set differently, right? The C as typeset in the math is italicized, whereas the C typeset in the text looks like text. If you've ever tried to use, if you ever come across a typo in one of your engineering books, you know how annoying that is. If there's multiple R's and they've accidentally typeset one of the R's to be the wrong way, it's really annoying because now the reader has to go through and try and figure out, is that a typo? Or were you actually referring to another symbol that was located somewhere else? And that's one of the powerful things about LaTeX is it makes it easy to typeset all of those consistently. The way to do that is to use what's called an inline math environment, which is the $sign. If you put a $sign on either side of A, either side of B, and either side of C, and recompile that document, you're using what's called an inline math environment. And you will get those to be typeset exactly as they appear inside the text itself. And that is a huge benefit anytime anybody's ever trying to read your document, because those symbols will line up. Whenever any of you get to 176, actually I'm not teaching 176, but I might still be doing the LaTeX intro to 176. I hit on that a lot because it's really easy to use multiple symbols to confuse your reader if they're not typeset appropriately. And so we stress that in 176. Other elements of math that you might need sooner or later, we're just going to kind of describe a few of them. One way is to put multiple equations in a line. So you can also gather up equations. And you can do that using the gather environment. And so you just say begin gather and end gather. And that says that tells LaTeX the stuff in between here is going to be several different equations on multiple lines. And so if I wanted to say, I don't know, we could put the Pythagorean theorem in there again. Maybe that's one of them. To denote or to tell LaTeX I want you to put the next equation on the next line, do a double backslash, and that shows up quite a few times. There's another question in chat for this line on line 23. No, you don't need a begin and an end on there. This is a shorthand notation of begin and end. But I will note in chat that one of your patterns of oh no, your pattern is okay. No, you don't need a special environment for that. It's the shorthand for that environment. The slash square bracket stands for begin equation star. It's just a shorter way to write it. So maybe you want to write the Pythagorean theorem. Maybe you also want something like the definitions of sine and cosine as being something like this. Sine of theta is fraction AC, and tangent of theta is fraction B over A. So here I'm demonstrating a couple math environments or math functions, right? So if I say slash sine, the result is to text or to format sine the way that you would normally see it, right? Not an italicized sign, but actually the function sine. We threw in some Greek letters there, so you'll get to learn your Greek alphabet. Lowercase theta is like this. If you wanted an uppercase theta, you just give it an uppercase theta. And then the fraction function accepts two arguments. The first is the numerator, and the second is the denominator. And so there's tons of different math functions. The easiest way to figure out what is the math function I need and how do I use it is to Google it, right? Just say in Google LaTeX create fraction, right? And you'll get half a dozen different walkthroughs that show you different ways to create fractions, which are great. So we're not going to go over every possible version. We're just going to show a couple of the most common ones. So I'm going to put this back to whatever. Uppercase theta is fine on here. Oh yeah, thanks, Eleanor. The quote thing in LaTeX is a little bit different. You have to use the double back quote, which is above your sort of back apostrophe, which on your keyboard should be next to the number 1. So if you look at the number 1 on your keyboard and then look to the left and hit that one twice, you'll get 2 of those marks, which are your opening quotes. And then your closing quotes should be over next to your enter key underneath the double quote, which is normally what we would say is an apostrophe. It's just a weird feature of, I don't even know if I would call it a feature. It's just a weird standard of LaTeX to do something like that. So if we look at what LaTeX did with those equations, we'll see that they all got lined up and they all got numbered, which is great. You can also use, if you are just going to sort of pile up math environment or math equations, that's fine. You can also use a very similar environment, which is called the align environment. And so if you just copy paste the whole begin, gather, end gather that we have right there and put it underneath here and change the word gather to align. If you recompile that, you will get the remarkably uninteresting result of almost exactly the same thing that you wrote before. So the numbers are updated, right? They went from 2, 3, 4 up to 5, 6, 7, but the appearance of the equations didn't change very much. The benefit of the align environment is if there is something similar in your equations, right? Somehow all of the left side is related, and so you would like them all to be aligned. Most often that happens because there's an equal sign somewhere. So if you put an ampersand, which is above your 7 key, next to each one of those equal signs and recompile that, you'll see that LaTeX will align everything based on where the equal sign is, which you see here. So now everything is nice and aligned here on the center. Again, the reasons that you might use that, maybe you have a bunch of equations, or maybe you're doing a derivation, right, where let's say you're expanding the square of a set of parentheses. And so the left-hand side never really changes, but the right-hand side gets developed a little bit. So we've got enough time. We can do another align one here just to demonstrate why you might do something like this. Let's say that x was going to be equal to a squared plus b squared. Actually, just a plus b. Let's make it easy because I don't feel like doing algebra right now. Right, and then on the next line down, you wanted to expand this. So this is a plus b times a plus b. And then on the next line down, you're going to finish your expansion and say this is actually equal to 2a, or sorry, a squared, see I can't do algebra already, plus 2ab plus b squared. All right, this is an example of where the align environment is useful because you can do a derivation like this, and you can see that the result leaves over here on the left as a blank, which is common because it's telling the reader nothing is changing over here on the left, and we just reproduce the equal sign. So if you don't have anything before the ampersand, it just leaves it as a blank and rearranges it. Right, so that's an example of the align environment. You'll often see the parentheses on here. This is the last math thing I'm going to show you because this is probably the most common one that comes up, is that the parentheses are usually ill-sized. So let's say for some reason that in here was not a plus b, but it was actually a fraction of a over b. Right? Ignore the fact that the math is wrong right now and just look at the typesetting. If you zoom in on this, it's typeset incorrectly. the parentheses shouldn't be tiny like this, right? They should be the full size of the fraction that's on there. And that's the last element of math that I want you to know about, because it comes up so often, is to tell LaTeX to make these parentheses or braces or brackets or whatever they are scale to the size of the input argument. And so to do that, we use what's called a left parenthesis and a right parenthesis. So a left parenthesis is /left followed by an open parenthesis, and a right parenthesis is a /right followed by a closing parenthesis. And if you recompile that, you'll see that the parentheses automatically scale to the content inside of them, which is the way that it should be. Which really covers just about all of the normal math that we typically encounter, things like fractions, powers. Subscripts are dealt with the same way. So instead of a superscript, like with the caret thing, you just do an underscore. So if I wanted it B sub 2 and A sub 2, I change those to A underscore 2 and B underscore 2. And that will change it around to be subscripts instead of superscripts. Between that, parentheses, and then functions like sines and thetas, or sines and cosines, or fractions, that's all of the major math that we do, right? Everything is pretty much just built up of one of those core symbols. If you need something fancier, like a matrix, it's usually, I often don't remember what a matrix code looks like until I need it, and I just go Google, LaTeX simple matrix and copy whatever their example is and modify it until I've got what I need it to be. Right, so math is a big chunk of what you would need to do in any kind of a STEM homework problem. That's one of the huge advantages, by the way, of LaTeX, is once you get used to what those functions are, and it doesn't take very long, right? It doesn't take long for you to sort of note in your mind, in order to make a fraction, I need the frac function, and the first argument is the numerator and the second one is the denominator. That's a mouthful, but you'll pick it up pretty quickly, right, after you use it a couple of times. Or sine is /sine and theta is /theta. It becomes so much faster to typeset your math in LaTeX than it does in something like Word or Google Docs, where you have to kind of type them all in one at a time and then click when you want something somewhere else, or highlight and say make that in parentheses. It's so much faster to do it this way once you get accustomed to doing it. And it doesn't take very long to get accustomed to doing it. It's so convenient, in fact, that there are a number of plugins for different programs designed to support just entering math by using LaTeX. So for example, MATLAB has a function or a text input. It's not even a plugin, it's actually built into MATLAB that allows you to enter math in the LaTeX form. Because it's just so much more convenient. So over in the chat, there are two questions over here. What's with the left and the right thing? That is telling, the left and the /right is telling LaTeX that these things should be scaling with the size of the input arguments. If you don't use the left and the right like this, then they don't scale, right? And they're just literally a parenthesis, like a text parenthesis. And so the effect of using left-right is to tell LaTeX, make the parenthesis look like this, where it's scaled to be the same height as the input argument, as opposed to just a standard thing. If you want multiple elements in the super and the subscript, usually, so for example, if you wanted 2 sub AB, right, and you tried to do just 2 underscore AB, what you would see is that the first one is subscripted, but the second one is not. And that's one of the most common places that you see typos, like in books and things, are people forgot to underscore both of them. I won't say the easiest way. The LaTeX correct way to do that is with a bracket. So if you put 2 underscore with a bracket around the AB, that tells LaTeX to put those both as the underscore. There's another way to do it, which is to double underscore it, but usually that sort of degrades the readability of your source code, and it becomes difficult to tell exactly what's going on in your equation. But the double, oh, actually now I'm looking over in the chat. Yeah, the double underscore is functional. It'll work, but it becomes a pain, for example, if you need text to show up down there, then that won't work. So for example, if you wanted cosine of theta for some oddball reason to show up as an underscore, you would have to use the curly braces here in order to put cosine theta as a subscript, which I don't think I've ever seen cosine theta as a subscript, but whatever. If you needed to do it, that's how you would do it. You know, text often shows up like that, and you need the brace for that. So the last two things that I want to hit, actually, Eleanor, do I have until 6? Is that when I should wrap this up?
As long as you'd like.
Oh, okay. I should be able to manage pretty much everything by 6, maybe 6:10 if we want to do the last one. I'll keep the last one looking simpler than I was going to do it. Second to last, if you're doing stuff in STEM, you often want to include a figure. So like a plot from MATLAB or a plot from Excel or something like that. So I'm going to use that as my second problem. So I'm going to give myself some white space here. LaTeX doesn't generally use that white space to mean anything. It'll just get ignored. And so if I wanted to start a new problem, I've been using sections. Let's go ahead and call this problem 2, including images. And let's look at what that recompilation looks like, just so you can see the default behavior. So notice problem 2, that next heading, again, its layout matches exactly what problem 1 was in terms of the heading. And then it ignored the like 6 spaces of white space that I put in here, which is standard for LaTeX. Most of the time that white space is ignored. There are some subtle times where white space is important. We'll kind of see an example of that here in a moment. In order to include images, we are for the very first time going to need A, to add a new package, and B, mess around with the file list over here on the left. So if you go back up to your preamble up at the beginning, we've got this list of packages that we're installing here, or telling LaTeX that we need to use, none of which require any special input arguments. Another very common one is what's called the GraphicX package. So the original package, you'll often encounter a lot of packages in LaTeX that end with X or start with X. So for example, there's mathptm X, and then there's GraphicX. There's another one that's very common called XColor. For whatever reason, the convention in LaTeX is if somebody makes a package and then a few years down the line, somebody comes along and makes a way better package that basically does the same thing, you say that that's an extension of the first one and you put an X after it. So GraphicX is the extension of the original package called Graphic, which they added a bunch of capabilities to. So we need GraphicX because we're going to use a graphic. And then the other thing that we need is a picture. So I'm going to make, I'm going to go find a picture. I'm going to find kittens. Your image can be anything that you want. I like that one. You're going to have to save this image to your desktop somewhere. Oh, wait, that's actually a really weird one. I've never seen a JFIF image before, so I need to make sure it's a standard image, like a PNG or something like that. There we go. That's a PNG. Purina weaning kitten. Perfect. So wherever you save that image, or however you get that image, whether it's, you know, taking a screenshot and then cropping it or exporting it as a PNG or whatever, LaTeX can't do that for you. You have to generate the image first, and then once you've got the image, you can import it into LaTeX. So in order to import that into LaTeX, over here on the left is an upload button underneath the word menu, and it should be right above main.tech. There's an upload button, and I'm going to go locate my file and drag it in here. Bum, bum, bum. Where did my kitten go? Oh, it's under downloads. Perfect. Purina kittens. Perfect. There's my kittens. So my now Purina weaning kittens image, 500 by 300 pixels, is over here, .png. I'm going to rename that because we're going to have to refer to it later. So I'm going to call it kittens because it'll just be a little bit easier for us to refer to the word kittens rather than whatever that other junk was, because we're going to need that here in a moment. So however you end up getting your image, my document here seems to have gotten squished a little bit. I'm going to reload this really quick because it appears to be bugging out on me. There we go. Let's go down here under, yeah, hopefully they don't have to keep extending GraphicX. They'll have to come up with another name. So we have to put the figure in there somewhere. So I'm going to give us a little bit of text. Actually, let's use lipsum. If we say lipsum1, we'll get a paragraph of text. And then in order to introduce some kind of a figure, we need another environment. And that environment is figure. So we need a begin figure and an end figure. The lipsum1 is just giving us a little bit of filler text, and the lipsum2 is going to give us some more filler text. And I'm just putting that in there so that we can see how the figure is being placed, where exactly that's going. To include graphics of some form, we use what's called the include graphics function. Should be kind of obvious. Once you know that that's what it is, it's like, yeah, sure, that makes sense. And we say include graphics kittens.png. That's why I renamed that file. If I had left it what it was before, I would have to try to type that perfectly right here. And that can be a pain in the butt. You will inevitably make typos, and it's challenging to figure that stuff out. So let's take a look at what happened over here in our source document, or in our compiled document. A couple of things happened. One of which is we got all of our text block to be right here. In fact, both of our text blocks are right there. And then on the next page, there's a massive kitten staring at us, which has actually gone off the side of the page. That's not uncommon because the resolution of that image was quite a bit higher, and LaTeX is bringing it in at full resolution and full scale. So in order to fix that, we're going to do a number of different things. The first one is provide an optional input argument to include graphics, and we're going to set the width of the image to be 3 inches. And LaTeX will automatically scale the width to be, or scale the height in order to get this. Yeah, if you got a box with the file name, it just means that your file name doesn't match what you typed. Right, so my file name over here is kittens.png, and I was very careful to also say kittens.png over here. If you're getting a box with a file name, it means there's a mismatch between those two. They need to be the same thing, and then it'll load your kittens. Or alternatively, if your image does not appear over here in your file browser, then that will also create the same thing. So make sure that image is over there. So the first thing we're going to do is set the width to be 3 inches. That'll make it a little bit smaller. We're also going to center it. So there's a, admittedly, kind of a weird function called /centering, which is this, which will center our kitten. And then the last thing we're going to do is put a caption on here, which can be anything that you want it to be. Right, short little caption on there so the reader knows what that is. So we have centered it. We have set its width to be 3 inches. LaTeX will automatically handle the height to keep the same aspect ratio, and we've thrown a caption on it. And so now if we recompile that, we should be in a whole different world where things look similar to the way that we want them, right? The kitten is now centered. It's roughly where we want it to be. But it's still kind of oddly set, right? It didn't show up here on the first page, and it's down here on the second page all by itself. This is both an advantage and a disadvantage of LaTeX. The advantage of LaTeX is it will handle most of the setting of spaces automatically. The disadvantage is every once in a while it gets one where you don't quite want it, and you kind of have to fiddle with it a little bit. This is an example of that, where it can be challenging to get the image exactly where you want it. Just because LaTeX is doing a lot of things automatically. Whereas with Word, you could kind of click and hold that image and drag it until it's up where you wanted it. You could, set wrapping around it and that kind of stuff in order to get it exactly as you want it. That kind of thing can be more challenging in LaTeX. And so you kind of have to release yourself from the desire of doing that sort of thing, so that you don't try to kill yourself figuring out exactly how to get that. My general suggestion for you is to start a new page for each of your problems. So if up ahead of your section you write /new page, that will shift the beginning of that problem onto a new page, and that can often fix a lot of these problems. So at the very least now, the problem and the image are on the same page. If you are absolutely dead set on needing that image to be exactly where you put it, right, in between two paragraphs of text, you can do that. The way to do this is first put a white space after the end of the word figure. So you've got end figure, and then we had lipsum 2, put a white space right there. And that will tell LaTeX, please put a new paragraph for lipsum 2. The other thing is to offer an optional input argument to the figure environment, which is H, right? So bracket H after figure. I'll highlight that. H tells LaTeX, try as hard as you can to put the figure here. That H stands for here. There's also T, which says try to put it at the top of the page, and B, which means try to put it at the bottom of the page. Sometimes LaTeX will do what you want it to do when you do something like that. So if we try this again, we will see that now the figure is in the middle of the text, right? And often I find that that's how people want it to be. They want the figure to be where they put the figure with the text. And so this is the easiest fix to do something like that, is to have a white space after the word figure when you close the environment, and to use bracket H to tell LaTeX that you mean business, right? You really want that figure to be here. There's a question over in chat. How do we exclude the figure 1 right here? Off the top of my head, I don't know how to do that. There's another package called the caption package, which allows you to customize what your captions look like. One way that you can do that is to just not have that line on there, but then you can't have a caption, right? If you just want the figure to show up in the middle with no caption, then just don't use a caption on there, and it will show up without the figure 1. That's a good question. How do you indent the paragraph? Don't. Let LaTeX handle the paragraph indentation. So if you notice up here at the top, the first paragraph is not indented. That's actually the standard when you start a new section or a new chapter or something like that. The very first paragraph in that chapter or that section is not indented. LaTeX has automatically indented the next one because that is the standard practice. Whenever you write a section in something, the second paragraph is indented, and LaTeX has automatically indented that for us. So don't put that in there. Yeah, if you're getting something called label, don't worry about labels yet. You can label it if you want to, but we're not going to label anything here. Yeah, it could inadvertently affect the text figure 1. If you don't do the label correctly, then the text will show up incorrectly up there. So labels are used for cross-references, which we're not going to get to in here. If you guys want to do a second LaTeX workshop, we can do stuff like cross-references. Cross-references usually don't appear unless you're doing a document that is actually going to be read by somebody in quite a bit of detail. Usually that doesn't pop up on things like homework. That's more for like a report that somebody's going to read, and they may need to refer to an equation that showed 5 pages prior to that. You can use what's called a cross-reference to do that, and that's what labels are for. Yeah, sure, we can do another one. But this one shows up a lot, right? Think about the class, or think about the types of homeworks that you could generate with just those 2 basic features of LaTeX. You can write really beautiful math equations, which may or may not be numbered. You can do derivations like this, leaving the left-hand side blank, so it looks like a derivation does. You can actually refer to those variables inside the text, and they look the way that they're supposed to. And you can include plots and figures and stuff like that, more or less where you want them to be. And that's with basically 2 environments, right? The figure environment and the equation environment. The very last one, which I've got until about 6:10 or 6:15, because I have to order dinner on there, so I have to stop. The last one that I want to do is how to put code into your documents, because quite often we need some kind of code. Maybe it's Python, maybe it's MATLAB. I'm going to focus on those two because those tend to be the most common languages that we use. But you'll see pretty quickly how to adjust it for other things. Let's do a third problem, for lack of a better word. So I'm going to start this one on a new page. I'm going to give it a section, and we're going to call this problem 3, including code. And that's about the last one. Like if I think to what kind of stuff do I need to do when I write reports or when I write homework assignments or exams or anything like that, it's these 3 elements, right? Put figures in there, put equations in there, and probably put code in there, because a lot of what we do has code. So let's give us a little bit of filler text. So lipsum 1 will give us a paragraph of filler text. And for the second time now, we need another package. So the package for code doesn't make a lot of sense, or at least it doesn't to me, because I haven't dug into it to figure out exactly why it's called this. It's called the listings package. LIS, like make a list, ING, like listing in a newspaper or something like that. A newspaper is like a print website for anybody who doesn't know that. And then plural, so listings. Right, the listings package is what allows us to do code, and that gives us access to another environment. So if we come down here and say begin, this is the other part that's weird. I don't know why it is this way, but it is this way. LST listing. List, it sort of reads as listing, except it's missing that I. It's LST listing. I don't know why it's like that. It just is. So the environment is begin list listing and end list listing, which is kind of a mouthful. And then anything that shows up in between there will be typeset as code. No, ancient Egyptians used tablets. They weren't as advanced as us. Tablets were like wooden web pages or clay web pages. So let's just throw some random stuff in here. A squared plus B squared. Let's assume we're using a language that doesn't require semicolons at the end. I'm kind of typesetting this as though it's Python. And then if you recompile that, again, I put a new page in here so that we can see where it's showing up. And so we did problem 2 is our figure, and down here is problem 3. A couple of things have happened here. Or I should say first, the font face has changed. So it's got this kind of like weird spacing in between letters that makes it look a little bit different. Usually, or more commonly in most languages, the carets will actually show up, right? Most languages don't actually show the superscript 2 as a superscript. It just shows caret followed by a 2. There are some math or coding languages where that will actually show up in the superscript, but most of them don't. And so this is what we call a listing, which is basically what we mean by code. If we want to set the language, right, so that the keywords are highlighted appropriately, if you have used Python, you would know that len is a keyword in Python, range is a keyword in Python, things like for and if and while and that kind of stuff are keywords in most languages. You can offer a secondary input or an optional input argument that says language equals Python after your listing, and it'll find those keywords and highlight them. And so, right, we now have len of C and range now become bold because it knows that these are Python style things. The listings package is amazingly flexible. Like you can reset your listings, your basically your code environments to look really, really different if you want them to look really, really different or very standardized or very neat, very nice. One way to do that, if we wanted to do MATLAB code, which we'll go ahead and do up here, is to use, there's a great package. If you want your MATLAB code to look prettier, there is a package, so use package, called MATLAB-Prettifier, which inputs all of the standards of MATLAB. So not only does it change the font face, it uses like the correct colors like greens and blues and purples and that sort of stuff. It has all the right keywords automatically highlighted, all that kind of stuff. We also want it to be numbered. So we want little code numbers to show up. So we're going to offer an additional optional input argument to the MATLAB Prettifier package that is called numbered. And that'll tell us that we want MATLAB code to be numbered as well. And then the last thing we're going to do, which is just like this is, if you look up like, how do I typeset code to look like Python? I mean, you will very easily find like 10, 15, 20 lines of code to make your code appearance in LaTeX just look ever so great. We're just going to use 2 lines right here. So the LST set function was provided by listings, and that allows you to set what you want your code to look like. So globally, we want our list settings to be such that the style is that of the MATLAB editor. So we say style is equal to MATLAB-editor. And we also want our margin on the left, which admittedly this is weird, and it's one of those things that can take a while to figure out what's the command that does this. We want the margin on the left to be 1/2 inch. So I said X left margin is equal to 0.5 inches. There is no way in the world that you would guess this. I have no idea how people did this before they had the internet. In fact, I don't think it happened before people had the internet, because you'd have to know somehow that that was the command. The documentation is good for that. So again, there are just, I would probably safely say hundreds of different settings that you can have that'll get your code to look correct. Correct being whatever you want it to look like. So if we change our code a little bit to make it look like MATLAB code, so length usually looks like that. Maybe we say for I is equal to 1 to, I don't know, length of D. And then we input the tab a little bit and we say, I don't know, E of I is equal to square root of D of I, and then end down here. Don't forget your semicolons if you're dealing with, now that we've switched over to MATLAB and we recompile that code. Right, what we get now is code that is typeset to look like MATLAB. So it has changed the font face. It's now what we call a Unicode font, or not a Unicode font. What's the word? The unispaced font. I can't remember what the name of it is. At any rate, it has set it to monospace. Yes, not unispace, monospace. It's a monospace font. It's got the keywords highlighted correctly, right? The 4 right here. If you were to throw a comment in there, it would just know that that is supposed to be commented. Actually it was supposed to, oh, sorry, it's get rid of language equals Python. That shouldn't be on there. It was probably getting conflicted between the two. There it goes. Right, so now the comment is green the way that it would normally be if we say S is equal to this is a string. It should format that in that beautiful magenta that MATLAB uses, kind of a purplish color, right? And so now my code would look great, basically all the time. Easiest way to do that, there are ways that you can actually link the two. So you could say if you're working over here in MATLAB and you update the code and you want that to automatically update inside of LaTeX, you can create a link between those two so that it just automatically updates, right? Every time you recompile your PDF in LaTeX, it goes and checks your source file and updates it accordingly. That does not happen very often in homework, right? You kind of, most of the time in homework, you just get the thing working over in MATLAB and then you just copy paste it from one to the other. And so that's generally what you want. The only time you really need that link is like if you're writing a report or a book or something like that, and you may go through and update that occasionally. That link is not, yeah, that's an advanced LaTeX thing, but it just doesn't come up very often. So usually we just copy paste the code for something like that. Right, that's a ton of functionality in what did we do, about an hour there. Maybe a little, count the first 10 minutes as just getting the thing up and running. In about an hour, we've covered all of the major things that you would ever need to do in a homework. Some of the things that we haven't covered are what we had mentioned briefly before, how to cross-reference. So if, on page 6, I need to refer to an equation or a figure that was on page 2, how do we set that up? Because LaTeX will do that for you automatically. There are some things that you can do that'll make it look a little bit prettier. So you can add things like nice headers up on the top, but that's, it's not critical. This is already a pretty nice looking homework. So we could cover that sort of stuff if we wanted to set up another one. Tables occasionally come up, but tables are actually one thing that LaTeX does not do particularly well. It's got a blind spot when it comes to tables. But between code, figures, and math, that's quite a bit. Yeah, sure, I'll pull up the preamble up there. So I'm happy to keep answering questions, but it's 6:15, so I'm going to put you on pause for a few minutes because I need to order dinner to make sure that it's ready to go. So I'm going to leave this up here. I'm happy to hang out until about 6:30 or so if anybody has questions, but I do need to order dinner really quick. So give me just a second and then I'll switch to Q&A mode. Eleanor, if there's anything anybody else wanted to add, I'm just going to sit here quietly for a moment.
All right. Yeah, if anybody has any questions, I can answer those. A bunch of people on projects can already answer those. Does anybody have anything they'd like to think about with MATLAB? There's this not MATLAB, LaTeX. Sorry, I know my own workshop, I promise. So yeah, is there anything? Where's the recording going to be posted? It'll be posted on AIChEprojects.org. That link right there. It'll be posted probably tomorrow, is my guess. Maybe the day after. Yeah, is there anything else we can answer for anybody? If you'd be interested in a follow-up intermediate LaTeX workshop, could you click yes in the participants window? Oh, that makes me so happy. I love that you guys love LaTeX. Will the LaTeX video be recorded? Yes, it'll be recorded and it will be posted on AIChEprojects.org. Yeah, you can't go back to Word after LaTeX. You can do all of MA 170 in LaTeX if you want to. It's probably a bit much, but you can do it. Yeah, it's a good thing.
There is another Senge 113 project this spring quarter. You can also do that in LaTeX. Great way to do it.
Let's see. Real quick, I'm going to switch to my slides. Just until Dr. Booth comes back. Okay. All right. So we hope you enjoyed learning about LaTeX. We will be sticking around for Q&A for a little bit if you'd like to hang out and learn a little bit more. If you haven't already signed in, please sign in. It really does help us figure out how we can make things better for you guys in the future. If you want to learn more about LaTeX, there's a whole lot of resources. You can search YouTube. I mentioned Physics 87 earlier. That is the freshman seminar that just teaches you how to use LaTeX. The this document that we have in the tiny URL here is something that Jared found recently, and it's amazing. And just practice. Like you practice and you figure out that you need to do something, so you Google it, and then you know how to do it from there on out. It's pretty nice. Like we've said a couple times, the recording of the workshop will be posted on AIChEprojects.org, probably in the next couple days, at most by the end of the week. And then please check out AICHE UCSD on Facebook. We have lots of things happening this quarter. There's something for everyone. So yeah, thank you to Dr. Dries, and if we could go back to Q&A, would that be a good time?
Yep, I'm ready whenever anybody's got questions. Ooh, somebody did MAE 170 in Word. I bet that was, you know, the pain of getting equations to be right.
I think I did it in Google Docs, and it was definitely a struggle.
Right, it can be done. It's not, you can get the point across, but often what I find when I'm using Word to do something like that is, like, I just get frustrated and stop because I don't know how, like, I just can't highlight the right thing to get the right thing superscripted, and I just give up. For whatever reason, maybe because I code more often, I'm more comfortable digging into it with LaTeX. Yeah, Overleaf's got really great documentation too. They've really lowered the learning curve, that sort of energy barrier to picking up LaTeX that used to exist. It's really not as bad as it has its origins in. What's the LST set supposed to do? So it's a two-parter, right? Some packages are complex enough that they have their own function that says, here's how I want something to look. Let me see here. Where did we use it before? Oh, Eleanor, would it be okay if I shared my screen again?
Yeah, absolutely.
So for example, let's look at the three sort of levels of packages, right? The Math PTMX package didn't need any extra input arguments. It just does everything we want it to the way that it comes by default. Some packages have a couple of input arguments that aren't enough to need their own function. So for example, geometry can be customized, right? By setting like page sizes and margins and stuff like that. And so we offered an optional input argument here of margin equals 1 inch. Some packages have so many settings that it becomes very difficult to use this bracket notation. And so they actually include their own function to establish the settings of that package. And so the listings package has its own setting function called list set, which establishes the style for listings. Geometry actually has its own as well. If you're trying to do something weird, like you need, certain spacing on the left, but you need different spacing on the right, and different spacing before and after figures or something like that, there is a similar customization function for geometry. We just don't use it very often. So the LST set function is how we enter settings for the listings package. Does LaTeX autosave? It depends on what you're using it in. If you're in Overleaf, yes, it autosaves. If you're using it on your personal machine, like offline, then no, not unless you've got some kind of an autosave setup. I mean, the same way that like Word doesn't autosave all of the time, right? Most LaTeX editors that you can use offline on your own personal machine do have some kind of an autosave setup, but it's like Word, right? Where maybe it's every 60 seconds or something like that. Overleaf, I believe, saves all changes. You can always look back in your history here over on the right, and you can see a lot of the changes that you've made as you've gone through and edited things. Yeah, the thing that I like to see if I'm grading a homework is a nice organization like this where I can see where your problem starts, but also where your problem stops. So let's say that you get down here to the bottom and you need to give, like, quote unquote, the answer. You would box the equation. So you'd say begin equation, end equation like you normally would, and you would say something like, I don't know, C is equal to 3.14159. If you just leave that as it is, you'll just get a nice equation that says C is equal to 3.14159. But sometimes it's hard to tell, you know, is that the thing that you want me to look at as your actual number? And so there's a function called /boxed that accepts arguments inside of math. And if you say /boxed, now you get a nice boxed answer, right? And that comes up often, right? The homework assignments will say box your answer. So there's a boxed option on here that lets you do that. There's also one thing that we didn't do in here that's related to that. Something that's really nice is to have units. So it's kind of a pain in the neck to typeset. If anybody did it for MAE 170, it's tough to typeset units. There's usually just a bunch of hacks that people use to, like, they just get tired of trying to typeset units, and so they come up with weird ways to typeset units. There's a package inside of LaTeX that handles units really well, and it does it according to the SI rules. And so once you get used to seeing the SI rules, it becomes really frustrating when people don't use SI rules because you notice it all the time. Hang on just a second. I need to respond here. So yeah, units and boxing equations and just sort of neat organization is what I would like to see in my homeworks anyway. I think most faculty would probably appreciate the organizational aspect of it. Units would be another good one that we could do in another LaTeX thing. Did I write 113 in LaTeX? Yep, all things in LaTeX. That's one where Overleaf would struggle with something like that. So Overleaf is good if your page count doesn't get beyond like maybe 30, something like that. If you're going to go too much beyond 30, it can take a little while to recompile things. And something that we didn't see here, and I don't even know if I would do this in like if this is beginner LaTeX and you guys want to go on to intermediate LaTeX, that's great. We can do things like, you know, units and tables and cross-references and stuff like that. Then there'd be another one that's more like advanced LaTeX. And I don't even know if it's really like advanced so much as you don't need this very often. And something that you don't need particularly often is multiple input files. But LaTeX really shines when you have a multi-part document because you can put those parts of your document in different files. And then only compile those files. So when I was writing that textbook, I didn't recompile the whole textbook every time I needed a textbook because a full compilation of that textbook would take 2 or 3 minutes. And I don't want to sit around waiting for that. So you basically just tell it only compile chapter 1 or only compile appendix C or something like that. And you would work on the individual components as you go. And then only when you're all ready to actually like sort of make a production copy of it, would you say, oh, okay, go ahead and compile the whole thing. But again, that doesn't, I give everyone in 176 a template that involves multiple documents just because it's easier to edit it when you have multiple people working on it that way. So if one of you is writing an intro and one of you is writing a background and one of you is writing a theory, it's easier if you're all in separate files, because when somebody in the results section pastes their code in for a figure, now suddenly if you're working below them, all of your code gets shifted off the screen. It's kind of annoying. So if you sort of divide it up among different files, then it's a little bit more convenient to use. But again, I don't even know if I would really call that advanced, more like it's just niche. It doesn't come up a lot. But it's easy to do if that's something that anybody wants to see.
have about 3 minutes left in the event if anybody has any questions. You have this LaTeX master here himself to answer all of your questions.
I have my teaching assistant with me too. This is my teaching assistant. That's Winston. He just hangs out next to me. Hi, Winston. I have 2 teaching assistants, actually. The other teaching assistant, though, is underneath the desk, and he can't see them down there. How do you add bullet points? It's another environment called itemize. So if you say begin itemize and end itemize, in order to create a bullet, it's the word item. Item again is the second thing in the list. And so you can nest itemizations, right? The way that's something that Word probably does a lot faster, because in Word you can sort of set up the bullets, and then when you want to move the bullet in, you hit Tab, and you want to move the bullet out, you hit Shift Tab. It's not quite as fast to do that in LaTeX. There are some shortcut packages available if you know you need tons and tons and tons of multi-leveled lists. There are shortcut packages that make it so you don't have to write begin itemize, end itemize every single time you want to change the level. So as an example, there's a package that would allow me to do something like star is the first level, 2 stars is the second level, 3 stars is the third level. But again, that sort of thing doesn't come up a lot. Itemize is one way. If you want to make it numbered, then that's called enumeration. And so the environment for that is enumerate. So instead of itemize, it's enumerate. And that'll give you a numbered list, right? It'll be 1, 2, 3, 4, or A, B, C, D, or something like that. How common is LaTeX in writing up research papers? It's a good question. I don't know. It was our standard when I did my PhD. Everything was written in LaTeX. But that was actually only after I got my PI to use LaTeX. So like the very first paper we wrote was in Word. And I showed him LaTeX afterwards because I used it in something else. And if you know that you need to do a bunch of math typesetting, you basically will not go back to Word, unless you have to go back to Word, because things like something as simple as getting the fraction and the subscripts the way that you want it to, if you fiddle around with that long enough in Word, and it doesn't take very long, you will get sick of it. And if you have the freedom to go to LaTeX and somebody has shown you to do it, how to do it, you'll probably not go back. So we used it all the time in LaTeX. All of our collaborators, which were there were about 4 or 5 of them at different universities, they all used LaTeX. That homepage that Overleaf has, that they're not lying when they do their little advertisement on here. Used by 6 million students and academics at 3,600 institutions worldwide. They're not lying, right? Caltech, University of York, us, UCSD. There's just a lot that use it. How long have I used it? I started using it around the beginning of grad school, which would have been like 2008, 2009, something like that. But it's just keep in mind, it's great. It has really strong advantages. It's really unlikely that you would ever use it in industry. Because in industry, it's not so common that you communicate to other research groups. You communicate to other non-technical groups. And most non-technical groups are not interested in math equations. They're not interested in cross-references and figures and that kind of stuff. but they are interested in being able to edit your document, right? They may need to change stuff in your document, and they will not want to use LaTeX to do that. So it's, you know, it's like anything else, right? It has its use cases, and where its use cases are called for, it's really good at what it does.
LaTeX is so cool. I wish industry would use it because it's just so cool.
It is, yeah. Again, like its drawback is it can't do things quickly, and it's not as widespread as Word, right? There is something nice to Word that just says, no, I just want that thing to be highlighted, right? I want to highlight this and click highlight and it's highlighted. If anybody wants a challenge for themselves, try to get something to highlight correctly in LaTeX. It's not easy to do in order to get it the way that you want it to look. So, but then again, it's not easy to do because the general typesetting guidelines is you should not have highlighting in your stuff. Like, when was the last time you read a book that had highlighting in it? It just doesn't, most people don't highlight stuff. So it's just a, you know, a case use kind of scenario. But some things that you think should be simple are remarkably difficult in LaTeX. Anytime you want to fiddle with alignment, that's tough.
Thank you for sharing the introductory LaTeX with us, Dr. Drews.
Yeah, definitely. I love LaTeX. It's so great. Is there a way to interact with the rich text editor? Yes, but I haven't used it. So you would have to teach me how to use the rich text editor.
We are super advanced LaTeX workshop.
It could be. Yeah, I don't know. I've never even actually pulled it up. Yeah, to me, that looks even more confusing because I don't know what's code and what's not. But if that works for you, go for it. You're very welcome to anybody who said thank you in the chat that I haven't caught up with. But I do unfortunately have to wrap it up. But Eleanor, thanks for reaching out. Appreciate it. This was fun.
Thank you so much. I'm glad you had a good time. We all did, I'm sure.
Yeah, and like I said, you know, if you guys want to set up another one for some of that other stuff, we could easily make another hour for it.
Right. I'm super excited. That'll be here in the future.
Cool. Sounds
anyway,
good.
Yeah, thanks everyone for coming. Thank you, Dr. Drews.
You're welcome.
Have a good night, everyone.
See you, everybody. Where's my log off button?
Hello.
So Shane, would you like to work on your code?
Yes.
All right. Let's see. I'm going to make you able to share screens.
I did not expect to be debugging on my yeah. Right here.
Eleanor, do you want to stop recording?
Oh, yes. Thank you.